So welcome back students. So today we are going to learn about how to convert octal to binary and binary to octal, or a hexadecimal to binary and binary to hexadecimal, or octal to hexadecimal or hexadecimal to octal. Okay, now this sounds a bit, there's so much of convergence, but it's pretty simple actually. So already we know that, if we have a binary number, and that binary number we are supposed to convert it uh, into a decimal number. So you know the procedure, right? We have done last time that we have to just take the binary number, then multiply by 2 raised to power to 0. Then the next digit, we will start from the right hand side, and then the next digit, if it is 0, so this is going to be 0 into 2 raised to 0. Then if this is 1, then this is going to be 1 into 2 raised to 1, and the next digit can be either 0 or 1, and so on. So this power gets increased, right? So 2 raised to 0. Okay, so 2 raised to 0 is what? It is 1. That you should remember. Okay, so why we are learning this is because we are going to understand the octal number system and the hexadecimal number system, and how the conversions are also very easy. If you really want to convert a decimal into binary, so decimal into binary, yes, the procedure is you have to keep on dividing it by consecutive division. We have to do perform that operation. But with this particular technique also, we can easily convert a decimal into binary. So 2 raised to 0, children, is 1. 2 raised to 1 is 2. Then 2 raised to 2 is 4. 2 raised to 3 will be 8, right? And then after 8, if you want more, you can have, that is 2 raised to 4. So 2 raised to 4 will be 16. Then 2 raised to 5 will be 32. 32, then 64, 128, and so on. So this power gets increased, it will go on increasing. So this technique, so I've taken just 4 bits. Now what are 4 bits is, like 4 digit binary number will be called as a 4 bit. For example, understand that if I take a number 1010, okay, so this is a 4 bit, and 4 bit, this is 4 digit 4 bit, 4 bit is called as 1 nibble. Okay, that's, I'll just increase the size a bit more, and that will be called as 1 nibble. Understand it. And normally in computers we have a data in form of bytes. We talk more about bytes. Okay, bytes basically is equal to, example, I will take some binary number. Okay, these are how many? 1 2 3 4 5 6 7 and 8, right? Okay, this is Excel is doing its work over here. It is not taking the bigger number. Anyway, just a minute, I'll just see to format this. Okay, Excel is doing its work, so it is not taking 0 0. So I'm going to make this maybe text. Let's see if this works or not. So 1 0 1 2 3 4 5 6, so 0 0. Okay, now it will be as it was. This is, now it is a text, and then I can also make this as center. So 8 bits will be 1 byte. Please understand this. So this is a 8-bit representation. So there will be 8 digits. So 8 bits. So 8 bits is equal to 1 byte. And then we have 32 bits and 64 bits of processors, isn't it? So that it's all depends upon. So if you have a 32-bit processor, the computer, and a 64-bit processor, so 64-bit processor is going to be much faster as compared to 32-bit, because 64-bit processor is going to carry 64 bit of data basically. You can say that. Okay, so that's how that it matters that how much what processor it is, whether it is a 32-bit or it is a 64-bit. Anyway, this is 8 bits. 8 bits is equal to 1 byte. Fine. And now what we are going to do is we are going to have the numbers. For example, this is a decimal number 1. Okay, then we have 2 3 4 5 6 9. And if I have to, now this is a decimal number, decimal, And what will be the binary of this? And let us calculate the binary. And let me also make this as well. This format cell, make this as text as well, so that there won't be any problem. Okay, so I will start. Okay, I was supposed to start with 0. Just a minute, we'll do it pretty fast. And 0, fine. So decimal of 0 and binary. Now if I have to represent this, I can represent this with 4 bits. So I will represent this with 4 bit. So 0 will be 0 for binary, and now this is 1. So what would be the binary number? Now if you come back to this, so see, this is 1, 2, 4 and 8, and these are also 4 bits. Now these are the values of 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. Okay, now I want 1. So what I'm going to do, I'm going to make this as off. 8 as off, that means 0. 4 as off, that means 0. 2 also off, 0. So 0, 0, 0 and 1. So if the binary is 0, 0, 0, 1, and that binary, if I have to convert that into decimal, I will use the same technique, that is 0, 0, 0, 1. So 1 into 2 raised to 0, and all these are 0. So anyway that is going to be 0, and then I will add it. So 1 into 2 raised to 0, it will come down to what? 1, isn't it? So I can straight away say that this is 0, 0, 0, 1. Now next number is 2. 2. So 2, what I'm going to do is, see, I want 2, so catch 2 over here, straight away 2 over here. So make this as 0, this as 0 and this as 0. So this will be 0, 0, 1, that is 2, 0, 0, 0, 1, 0. So if you take 0, 0, 1, 0 and as a binary number, convert that into decimal. So what you will do, you will take 0, 0, 1, 0. So that is 0 into 2 raised to 0 will be 0. This is 1, so 1 into 2 raised to 1, right? So that is what? 1, yes. So that will be, yes, that will be 2, and this rest all things will be 0. So decimal will be 2. So 0, 0, 1, 0. I hope you are understanding this. So 2 will be 0, 0, 1, 0. Now if I want 3, how I'm going to come up with 3? I can simply write this as 0, 0, 1, 1. Why 1, 1? See, this is 1 and this is 2. So if it is 0, 0, 1, 1, so I have to simply add 2 plus 1, isn't it? And that is what I'm going to do. That is, if it is 0, 0, 1, 1, so 1 into 2 raised to 0, that will be 1. And this will be this will be also 1. 1 into 2 raised to 1, that is 2. And then I'm going to add it. So 2 plus 1, 3. So 0, 0, 1, 1. So 2 plus 1, that is 3. Now if I want to come up with 4, so how I can come up with 4? So this is 4. So 0, 1, 0, 0. So simple, isn't it? So 0, 1, 0, 0. Now if I want 5, so that is 4 plus 1, 5. See, this is 4. You can straight away add 4 and 1. And rest of the things you can keep it as 0. So 0, 1, 0, 1, right? So it will be 0, 1, 0, 1. So that's 5. Now I want 6. So 6 will be 0, 1, 1, 0. 4 plus 2, 6. And if you convert that using that technique, it will come down to 6, children. Okay. So 0, 1, 1, 0. 4 plus 2, 6. So this is 0, 1, 1, 0. Then 7. 7 will be what? 0, 1, 1, 1. And now we are going to stop over here. Why 1? See, you can see. This I have to keep it 0. So 4 plus 2, 6 plus 1, that is 7. Fine. Now we are going to stop over here, and the reason I said we are going to stop over here is now I want the octal number of this. So if a binary number, if it is, octal number for this will be 1. This again I have to convert that into text and center. Okay, this is 2, this is 3, this is 4, this is 5. Oh, this is 0, 1, 2, 3, 4, 5, 6 and 7, right? So octal, these are the octal numbers. Now children, can you tell me how many bits octal number takes? These are 4 bits, right? So how many bits octal number will take? Octal number will take 3 bits, only 3 bits. Even if I remove this 0 from here, so this is basically, I just need to remove 110. Okay, I'll do this so that it will be clear to you. So octal number system will actually take 3 bits. Okay, I can represent 0 to 7 using 3 bits, isn't it? See, fine. And if I say hexadecimal number system, a hexadecimal number system, and even this will be, I'll just copy this and paste it over here. Now we have done with octal number system. So octal number system, like this is how they are represented, 0 to 7. So if I say 7 octal number system, the binary will be 111. If I say 4 octal number system, the binary will be 100. Fine. And now if I get see 0 to 7, it is only taking 3 bits. But if you look at hexa, so hexa we have total 16 symbols. So if I go for 8, now there is 8 out here. Why this is not taking center? Okay, so now 8. So 8 is going to take how many bits? So if I want to form 8, you come down over here. So this is 8, 1 0 0 0. This will be 1, rest will be 0. So hexadecimal number system, children, takes 4 bits. Okay, I'll complete this. 9. So 9 will be 1 0 0 1, isn't it? See, 8 and 1, 8 plus 1, rest 2 will be 0. And then 10 will be, see, 8 8 and 2, 8 2, so 1 0 1 0, right? So let me just go over here. So 1 0 1 0, and that is what? A. That's the hexadecimal symbol. And then 11. So 11 will be, this is 10 and this is 1. So 1 0 1 1. So 1 0 1 1. That is what? That is B. And then will be 12. So that is 8 plus 4 straight away. That is 12. So 1 1 0 0. That is what? C. That's 12. Then 13. 13 will be 1 1 0 1, right? 12 and that 1. 8 plus 4 12 and 1 13. So that will be D. And then 14, how I'm going to have? That is 1 1 1 0. Then 8 plus 4 12, 13 14. So 1 1 1 0. That is 14. That's E. And then last, all bits will be occupied, and that will become F. See, total we have 16 symbols, and how many bits it took for the hexadecimal? Maximum it took 4 bits till F. Now after F, then there comes the combination, right? After F will come the we will have the combination. Similarly for over here, after 9 we have the combinations, right? So after this we need a combination, and then that one more bit it is going to take up. Okay, so that is how it is, children. So using this technique, now see, if I want to convert any binary to decimal, so definitely there is some calculations that we have to go through, understand it. But if I have to convert binary to octal, or octal to binary, binary to hexa, or hexa to binary, or octal to hexa, hexa to octal, it is going to be very simple. Okay, for example, here is a number 10110. Okay, this is the binary number. Okay, this is the binary number. I hope it is visible to you. This is the binary number, and I have to convert this binary number into octal. So octal takes how many bits? It takes 3 bits. Fine. So just form 3 bits from the right hand side. just form 3 bits, a group of 3 bits. So I'm going to form these 3 bits. Okay, let me just show it over here. I'll take new, otherwise maybe it's, I don't know whether it's visible or not. So I'm going to delete this and this, insert, I'm going to go to text and just do this. So 10111, okay, I'll take that as 5 digits, and let me just increase the size so that it's pretty visible to you. That is too big. Okay, so now let us do this. So what I'm going to do is, if I want to convert binary to octal, we don't have to do any calculations. Just we have to form the groups from the right hand side. So if I do from right hand side, I form the group of 3. Why 3? Because I want to convert this number into octal. Octal takes how many bits? 3 bits. Okay, and I proved this, why it is taking 3 bits. See over here, maximum it takes 3 bits, right? So I'm going to form a group of 3 from the right hand side. So the first group that I will get is the 3 bits, that is 111, and then I'm going to simply write the answer of this. What is the answer for this? So let me just have one more text, insert and text. So let me write the answer over here, and that's pretty small, so I'll make it big. Okay, so what is the, okay, let me just keep it this way. What is the answer for this? That is 333. And what is the octal number for 111? So 111, the octal number is what? 7. So I will simply write this as 7, right? And that is the group. This is what I found with this, making that group. When I okay, when I made this group, so 111 is what? 7. So I will write 7 first. Okay, and then you have to keep the same order. Okay, do not worry, make sure that. And then from here you have 0 1, sorry, 1 0, and then we require 3 bits basically. So what you're going to do, you're going to simply add a 0 out here. Okay, let me just make this a bit smaller, and simply I will add a 0 over here. Okay, from the left hand side. So now this makes it even. So this is 777, that is 7, and this is 010. So what is 010? So 010, that is what? 2, isn't it? So I'm simply going to write here 2, and that's my octal number system. So easily I can convert a binary to octal, and octal to binary will be also the same thing, just this thing will come down and this thing will go up. If the question is convert the the octal number to binary and the number is 27, so what you're going to do, 7, you're simply going to write 111, and 2, that is 10, and you're just going to add one extra 0 out here, and that's the binary number. See, even if you do not give 0, you convert this, it's okay. It is like 0. Okay, do not worry about that. But if you are having a binary number, converting that into octal, so you need to form that group of 3. So you need to add that 0, form the group, and then you can write the number. Okay. So you can convert octal to binary, binary to octal is pretty easy. And similarly, even a hexadecimal number, for example, if I say that A F A, this is a hexadecimal number. Okay, convert this hexadecimal number into binary. How you're going to do that, children? So A, what is A, children? A is, I think, 10, isn't it? That is 1010. You know that. So you simply write for A, it is 1010, right? That's the first. See, you can make a separate block if you want. I will do it this way so that this is understandable by you. You can understand this now. So this A becomes 1010, and then I'll copy paste this this F will become what? This is all triple one, simple as that, right? And again we have A, so again that will be the same number, that is what? 1 0 1 0 1 0 1 0. So you can see these are the numbers. So AFA hexadecimal, if I convert that into binary, and this is what I am going to have. So the conversion is very simple, and that is why we have the octal number system and the binary number system. So, and if it is possible that you might get a question that convert the binary to hexa. Binary to hexa. So what is the procedure you're going to apply? Same. You're going to start from right hand side, form the group of 4. Okay, break down, make a group of 4 from the right hand side. So that is 1010, that is A. Then the next group was all 4 are 1, that is F. And again 1010, that will again become it A. And if it is something like again one more 1 out here, okay, if that's the binary number that you have, then what you're going to do is again this one you're going to make it as a different group, and that will be, and add the zeros. So this will be, I will okay, this one I'm going to make it separate. Okay, so if it is 1 over here, so I formed the 4 group, 1 2 3, I got A F A. Now this is 1, and then I'm going to add zeros before 1, 3 zeros, fine, and that will make 0 0 0 1. And what is that? That is 1. So that will be 1 A F A. That's the hexadecimal number. So you can see, children, that conversion of octal into binary or binary to octal, it is very simple. Now if you really go into assembly programming, system programming, so you're going to make use of the memory address, and most of the time you will find your memory address in form of what it is over here, that is in the form of hexadecimal number, because you can see it is simple. This is just you can say 4 digits, or this is a we require only a 4-digit number, you can say this. But if you convert that into binary, it is going to be huge stream, isn't it? So that is why we have this number system. For circuit designing also, this becomes pretty easy to to design a circuit, understand it, a microprocessor chip. So this becomes pretty simple. So this is the whole thing, children. And then tomorrow we are going to convert octal to hexa, hexa to octal. Even that conversion is pretty straightforward and pretty simple. Okay, children. So please practice this. I'm not going to give today any homework. You have one chapter, that is software concepts, for the upcoming unit test. You can keep a study that. Few of you have submitted the homework to me, and I'm just going through that, children. Okay, I will just go through it and let you know. Do not worry about that. But right now, children, just focus on your upcoming exam, and the question can be asked from anywhere of the chapter software concept. That's the only one chapter, fine. So that's it, children. Then tomorrow we will learn some more techniques, and about octal to hexa, hexa to octal, and then there are some other things also we are going to learn in number system. So that's it, children. Right now I'm just signing off. Okay, bye.